In order for f of x equals a to the x to exhibit exponential decay, a must lie between 0 and 1, not including either of these numbers. When a is in this interval, the value of the function is multiplied by a fraction each time x increases, making f of x get smaller and smaller. Let's experiment with this for a second. Here we are back in friendly old Desmos, and I've typed in the general function that we've been talking about, f of x equals a to the x. I've made a into a number that I can adjust by sliding this right here. Right now a is set to 1, and as we calculated before, this is just a horizontal line, f of x equals 1. Now let's see what happens as I decrease a. You can see right away, just when I let it go below 1, we already have a function showing exponential decay. As I continue to make it smaller, the decay gets more and more steep. It's happening more quickly. That's going to continue to happen until a gets too small. When a reaches 0, we have that constant function again. Except this time, it's at f of x equals 0. We can, of course, also slide over into the exponential growth area as well. That would just mean we need to increase a past 1. Let's try that. Here we are back in our exponential decay, and there we go, we're growing. Just above 1, we already see that new pattern forming. And the growth gets steeper and steeper as a increases, since we're going to be multiplying by more and more each time x increases. If I let a get really big, our graph's going to increase at an incredibly quick rate. I would encourage you to visit the Desmos website and play around with this on your own. It's really fun to see how many different things you can do with exponential functions.